Good afternoon, everyone, esteemed delegates, distinguished speakers, colleagues, and friends. It's given me immense pleasure to welcome you to this technical seminar being held in conjunction with the 48th ECM meeting here in Yangon. Our technical seminar today focuses on the theme Disaster Resilient Infrastructure in Coastal Areas and Cyclone/Typhoon Risk Mitigation. This theme is pressing and increasingly urgent one. Coastal regions around the world, and particularly in Asia and the Pacific, are on the front line of climate vulnerability. These areas are home to hundreds of millions of people. They host critical trade and economic infrastructure and form the backbone of many nations' food and water security. Yet, they are also the regions most exposed to the escalating impact of extreme weather events. Cyclones and typhoons have grown more intense and frequent due to rising temperature and shifting wind patterns. When these storms make landfall, they unleash a dangerous combination of high wind speeds, often exceeding 150 to 200 kilometers per hour, and torrential rains, sometimes exceeding monthly rainfall averages in a single day. This twin hazard leads not only to wind-induced structural damage, but also to large-scale inundation, riverine flooding, storm surges, and landslide. The risk landscape is further worsened by several compounding factors. Climate change is increasing baseline vulnerabilities, while rapid urban expansion in coastal areas often outpaces planning norms or resilience considerations. Much of the built environment remains aging, non-compliant, or inadequately maintained, and the institutional capacity to respond to such disasters remain constraints in many regions where we are involved. As a result, cyclonic events now frequent test the limits of our infrastructure systems, from critical transport corridors, bridges to essentials lifelines like power, water, healthcare, and education. In many recent disasters, community shelters, schools, hospitals have either been overwhelmed or structurally compromised, endangering lives at the very moment they are needed most. These sobering realities reinforce why our discussion today is so timely. Building infrastructure that is not only strong but smart, adaptive, and inclusive is no longer a choice but a necessity. It requires bringing together engineers, policy foresight, technological innovations, and above all, community resilience. At TC-32, we recognize that building resilience in such regions requires an integrated approach to include advancing engineering standards and codes, harnessing technology and innovation, empowering our communities, and enabling cross-border collaboration and knowledge exchange. Over the past 1 year, TC-32 has continued to strengthen its global network of experts. Today, we continue that mission through a carefully curated session featuring speakers who bring a wealth of technical, institutional, and grassroots insights. Ladies and gentlemen, please allow me to introduce our distinguished speakers, each one of whom will address a critical dimension of disaster resilient infrastructure. Firstly, we have Professor CVR Murthy from the Indian Institute of Technology, Madras, from IC India. He is a globally respected civil engineer specializing in disaster resilient structural engineering. He currently holds the PS Rao Institute Chair and leads multiple national technical committees under the Government of India, including the Bureau of Indian Standards and the Ministry of Earth Sciences. He will be speaking to us on engineering standards and policy frameworks for cyclone resilience. His presentation will focus on the uneven maturity of cyclone resilience standards across countries, and propose the development of unified design codes and multi-hazard policy frameworks. He will argue that long-term risk mitigation must go beyond early warning systems to embed resilience into engineering design. Next, we have engineer Suraj Gautam from the Institute of Himalayan Risk Reduction, Nepal. He is a civil engineer, a DRR specialist, and executive director of IHRR. He has pioneered the use of low-cost early warning technologies, citizen science platforms, and drone-based risk assessments in the Himalayan region. His topic will be technology and community resilience, Nepal Cloudburst 2025. His talk will share the compelling experience of Dodra Chandani municipality in Nepal, which experienced a record-setting cloudburst in July 2024. Thanks to a proactive use of technology, early warnings, and local networks, the area experienced zero casualties. He will showcase the role of DASTA system in real-time visualization, household targeting, and anticipatory action. Next, we have Dr. Manish Mokal, who is on the dais here from AFCON's Infrastructure, IC India. He is an accomplished civil engineer and infrastructure specialist at AFCON, one of India's leading engineering and construction firm. With over 2 decades of experience, he has led several high-impact projects in challenging marine and coastal environments. His expertise lies in integrating advanced material science with field implementation to deliver robust and adaptive infrastructure solutions. He has led post-cyclone rehabilitation of marine infrastructure in India and bring deep field experience in the design of robust, long-lasting coastal infrastructure. His topic will be advanced materials and technologies for resilient infrastructure. Finally, we have Mr. Pyae from the Federation of Myanmar Engineering Services with over 12 years of experience in disaster preparedness, recovery, and environmental education. He has played a lead role in Seeds Asia's project across Myanmar. He has coordinated efforts for school safety, shelter planning, and disaster awareness education in the Ayeyarwaddy Delta region. His topic will be community-based preparedness in Hinthada Township, a case study. He will highlight the model case where local communities co-developed participatory disaster management plans, trained volunteers, and constructed school-cum-shelter facilities. The project demonstrates how grassroots ownership, training, and indigenous knowledge can strengthen disaster response capacity. After all the speakers have given their address and talked on their topic, we'll have a panel discussion on policy, innovation, and community engagements, an interactive question and answer session with the speakers and our audience here. The aim and the goal being to co-create scalable, resilient infrastructure strategy. So in closing, let me reiterate that this session is not only about technology and standards, it's about shared resilience. We must bridge engineering ingenuity with community insight and political will to ensure no lives are lost and no communities are left behind. Thank you, and let's now commence with the technical presentations. I think I'll first invite Professor Murthy, who has already joined us. Sir, have you joined us, sir?
Yes. General Sahab, I am in. Hello, General Sahab, can you hear me?
Yes, sir, I can hear you, sir.
Yeah, let's start the presentation. Can you see the screen?
Yes, we can see. Yeah, we can see your screen. Yeah.
Yeah, thank you. Good afternoon, ladies and gentlemen. A pleasure to be part of this panel discussion related to cyclone resilience. I'm keen that I just present the highlights of what we need to do different from what we have been doing all these years. So quickly, today's presentation will be about the double trouble that cyclones offer us, which is both wind and water, then the need for robust standards, and then finally, we'll talk about the way forward, what we need to do. But in all this, the backdrop for building resilience in the built environment and thereby in the communities are robust standards, strong techno-legal regime implementation. These will remain our key watchwords for the way forward. First off, let us talk about the double trouble that we have. Nature has 5 elements in it, and cyclone takes the fury of 2 of them simultaneously. Very unusual. Normally in design practice, only one is expected at a time in the design process. That is the assumption one is made. But cyclone brings a very special combination of wanting to design for 2 simultaneously. And when you look at the 18 loads that appear on the structure, the wind and the water loads, both are force loads, and hence there is a need to build robust standards. And I'll explain why these robust standards have to be done. Now, the 18 loads that are there group under natural and man-made loads, and natural hazards are seen to follow a Poisson statistics, while man-made hazards follow Gaussian statistics. And hence, it is in the recent times, in the last couple of decades, we have moved to estimating the natural hazards based on return periods and not on characteristic values or Gaussian statistics. Now, for example, this has been successfully implemented in a case of earthquake design, and where we have considered all our built environment into natural, normal, important, critical, and special structures. And return period forms the basis. So the larger is the return period, more severe is the consideration of the force. And that is the approach that we have been taking. And it is now time for us to look at the second segment of our discussion today, is that the robust standards that we have, how do we really create such robust standards? So first off, in the case of flood also, we will need to look at 4 set of structures, which is normal, important, critical, and special, and then look at the flood levels that we need to consider in the design of such structures. Why is this necessary for us? Because first off, in the existing built environment and also the new one to be added, we need to assess the risk that the built structures are at from the consideration of flood. And hence, we need to move to a probabilistic framework. And while some countries have done this successfully, many of us still have not moved to that in this because of the lack of data in availability in a formal sense. Because in the case of flood and wind, we need to worry about local conditions. So this database needs to be maintained consistently. And internationally, the probabilities that are acceptable for the design of normal, important, critical, special structures are 20% probability of exceedance in the 50-year design life, considered design life, to 10 to 5 to 2 years, 2% of probability of exceedance. Now, in the case of flood, a new paradigm has come into our discussion, that is climate change. So if you consider climate change, the surprise will be much higher, and hence it is time for us to bring that into the design process. So the increase in the incremental water level as you go from the return periods of 225 years forward is to be examined. In the case of earthquakes, the best available estimate based on paleoseismology and the fault movements over the past earthquakes has been slated as 2,500 years. But in the case of flood, the best available data is not more than 200 years, and hence that becomes the reference return period, and anything higher than that is actually to be estimated. Now, we can look at the way we are designing right now and revise that method from mere statistics to return period approach, and also add a climate change factor on top of that. This would be a simpler method of handling the hazard level as far as flood is concerned. Now, when it comes to wind, Many countries have also moved to the return period method, but many others are yet to have this step taken. So it is time to again harmonize the wind estimation of the wind forces also under the same return period concept. Now it comes to, that's on the demand side. On the capacity side, when you design structures, you design normally for strength, and then you have serviceability, durability, robustness, integrity, and restorability as the six limiting states that we have to design for. In the sequence, we are looking at strength design first, serviceability next, durability is considered en route, and then we have robustness, integrity, and restorability in that order. Not all structures need to be designed for these, all six of them, but for sure the first three are mandatory for all structures. So while we design for strength, we will consider durability and check for the others. That is the approach that is taken. Now, when you look at such a design framework, you notice that as you permit more damage in the structure, you're increasing risk. And as you reduce the damage, you're increasing resilience. And this is where we need to make a departure now. All these years, we were rather accepting the amount of risk or putting that numbers into it and then saying that this is the level of risk, this is acceptable and so on. But now I think we need to depart from that, because we can't keep rebuilding all these facilities over and over again, especially in the case of cyclones, where we are looking at annual recurrence. We need to have resilience built in, which means the design standards have to change now from a risk-based approach to a resilience-based approach. So that's where the robustness of the design standards comes into picture. When you look at life cost, you realize that it might seem that it's going to cost a little more, but when you look at the life cycle cost, even the risk-based design is also going to cost more. And there is a kind of an optimum in between that we can start with initially, instead of going whole hog complete resilience, and then slowly tighten the clauses as we go forward in each 5 years or 3-year window. We can improve the clauses and finally have a destination of a complete resilience. This would be my recommendation for the annually recurring loads that we have, like in the case of cyclone. So what it seems like is, on one side, the loading standards, we need to improve the hazard estimate by bringing in probability. On the other side, the design standards, we need to improve the robustness by examining the structural capacity and estimating the amount of damage. And that is essential at this point of time if you want to bring back the importance of the dignity to mankind in terms of the flooding that is happening regularly. So it is time to redo the design standards to build resilience into that. It's not the same as the risk-based design. And so we need to think together and then create this. Finally, I would like to say that in the past, we have always been focusing on risk and say we have three elements contributing to risk: hazard, vulnerability, and exposure. Hazard, we use science to estimate. Vulnerability, we used engineering to estimate. But exposure is still in the hands of the municipal bodies through the bylaws. And so structural safety was hinging also on the bylaws that were allowing a lot of freedom to certain structures being developed in vulnerable areas. And this is where I think we need to put some pressure on in trying to relook at the bylaws also, improving the engineering estimates, as well as improving our understanding of science of the cyclones. So on the risk side, when you look at it, vulnerability assessment forms the backbone of risk assessment, and this can be performed at three different levels. The first two are qualitative and the second two are quantitative. And it is necessary now for us to move to quantitative assessment and can't survive on qualitative assessments anymore. And vulnerability assessment has to go into bringing out exact numbers and exact deficiencies in structures. But you would notice that you won't do the entire building stock at all the rigorous level. You will start a telescopic method. You will pass all structures through level 1, low rigor and low time taking, then bring level 2, which is also qualitative, then bring level 3, which is quantitative but simplified, and then bring the detailed quantitative. It so happens that if you look at the number of structures that will go through this filter, if you start with 5,000 at level 1, finally you'll end up at 5 structures to go to level 4. So it is not so bad when you look at 50 structures to be evaluated quantitatively out of the 5,000 through a logical sequence of filtering. So it seems that the problem may seem large, but it is still doable by the engineering and architecture community worldwide. But one thing that embarrasses us is when you look at flood, this has been the most painful question, that should we allow people to go through this process every year, every time there is a cyclone or every time there is a high flood condition? I think it is time for us to give dignity to mankind. And even though we have been talking about people, property, and business and finances as far as numbers are concerned, I think mankind has to be put higher. Now, out of the two hazards that we have, one is flood and the second one is wind. We notice that retrofit can be done only for wind-related systems. And while all new structures will have to be built with the revised standards, the old structures also, we need to now reduce the number of vulnerable structures and then increase our building stock towards safety rather than to leaving them at the unsafe conditions. So this is a very difficult task. Retrofit is not easy, but I think we have to be systematically doing this through prioritization of our assets into 3 boxes: high risk, medium risk, and low risk. What we notice is robustness of structures is needed against wind. Wind knows nothing other than the fact that is the structure able to resist the level of pressures that it is imposing on structures. If it is not, then I think there's definitely need for help on our structures. Also, how long will we keep on doing response? And how long will we keep evacuating people? At some point of time, we are clear that the people are not alone, but they are lonely because the technical bodies are not giving them clear statements. I think we need to support governments by giving them very precise statements as to what is doable and what is not doable. I will close by saying that flood knows only elevation and wind knows only obstruction. As far as flood is concerned, we need to live above that high flood level, and we call this compliant design. And as far as wind is concerned, we need to face it and do the defiant design. Clearly, flood is a planning matter and wind is a structural design matter. So what we need is actually robust standards that we can collectively, through all the membership of the ACECC, coming together and creating with the best practices across the countries, and also get governments to look at some policy matters related to planning, land use planning for the future developments. So I'll put the strategies in 2 boxes. One is short term. As far as wind is concerned, we need unified good engineering design practice related to the built environment, improve the standards as far as hazard is concerned, make them robust, improve the design part of it, where especially when we look at resilience, it is not possible for us to now admit so much of damage in our structures. And so for wind particularly, the configuration of the structural configuration of structures also makes a big difference. Very clearly, where we are falling short in many countries is actually strong techno-legal regime. We are not implementing the standards that we are creating. Even whatever is available, we are not implementing. And that is why we are jeopardizing a lot of people living in low-lying areas and living in structures that are vulnerable to wind action. On the flood side, the focus should be on mitigation and not on preparedness and response. As far as mitigation is concerned, we need land use planning, and we need to, in the long run, move people out of the low-lying areas because water knows nothing other than elevation. On the other side, we will have to painfully go through the process of preparedness and response because we have a large stock of buildings and structures in low-lying areas. So we need to forecast, we need to do early warning, and we need to do evacuation. But all this is out of compulsion. This is not the solution in the long run. The solution will remain only on the mitigation side. This is where I think a strong policy is required. We need to help governments understand the importance of bringing back dignity to mankind by giving them an advantage. So it's very clear to us that there are a number of countries which have very good practices, and we want to borrow all those good practices and put together a considered document which can become a model document for countries to adopt and adapt and even customize it to their conditions. But it is time that a body like the ACECC comes together and creates this necessary backdrop. It's not time to watch anymore. It's time to get into action. With about 20 people on the floor on the stadium and 20,000 watching them, I think we need to reverse it. Only the elderly should be watching. All of us should be continuing to play the game. I will stop here by thanking the Asian Civil Engineering Coordinating Council, the Chairman and the General Secretary General, and the Indian Institution of Civil Engineers India, the Chairman and the Vice Chairman. And ladies and gentlemen, thank you for your time and attention.
Thank you, sir. I will request you to please be online for the interactive session.
I will. Thank you.
Now I will call upon Engineer Suraj Gautam to deliver his talk, please.
Thank you. Thank you so much, sir. So am I audible and is my screen visible?
Yes, you're audible and the screen is visible.
Okay, thank you so much. So first of all, thank you so much for providing me with this wonderful opportunity. And I think the first presentation has already set up the stage and it has given some very good and bold remarks that we need to follow up. But besides that, in my presentation today, I'll be talking about some of the recurrent problems that we're facing and how the use of technologies and community participation and their not just participation but their meaningful engagement has been resulting in saving lives and also the livelihoods. So although Nepal is not that much affected by the coastal other problems, but we do have a number of hazards that is posing some significant risk, and we are all aware about the natural hazard induced disaster that has been severely affecting us. So I won't go much into this. Besides, if I have to talk about the floodings in Nepal, so if you look at the 50 years average of data, then you get to see that on an average, there is at least 83 deaths per year. So it is based on our historical data, and it's not just about the lives, but also the damages, loss and damages in different sectors that has been continuously we are facing it. And apart from that, one of the very speciality of what do I call it, speciality or so. So in Nepal is the complex geography. And if you look at the elevation difference of Nepal, so the Tarai, the southern part of the country is around 60 meters of elevation, whereas the topmost northern part is almost up to 8,848.86. So within the just variation of 200 kilometers of aerial distance between the northern part and southern part, it is just 200 kilometers, but the elevation varies a bit. I mean, it's a big number. And besides, the complex geology and other problems has also been resulting into this kind of issues. And regarding the floods, I already shared this. So what's the problem, what we are facing right at this moment? It's all about, people often call it, we lack data or so, but it is not just the data, but also the approaches that we have been following, and also regarding some of the works that are more focused on the response rather than being very proactive, investing in mitigation and also the preparedness. So these are some of the cloudburst events in Nepal, and I believe I was I was not even burned while this kind of cloudburst event happened in Nepal. So the latest one was from 1993. It was in the central Nepal, and it resulted into the death toll of more than 1,300 people. So it was a quite devastating one. So for this year, 2024, for the last year, you can see how the country is facing the spatial variation of rainfall across the countries. So today I'll be talking about one of the case study from the far western part of the country. So I'll be giving information about that. So it was kind of 5 days before my wedding when I was set to leave. But then because of this emergency, I had to return back to work regardless of my wedding ceremony. So between July 7 and July 8, for the period of around 24 hours, it was almost 624 millimeters of rainfall that happened on a single 24 hours of duration. So if you look at the rainfall of July month in that region, so the total monthly rainfall was around 1056 millimeter, but on just one day it was around 624 millimeters. So it speaks of about the massive amount of rainfall, and it is also because of the interaction between the monsoon rain that comes from the Bay of Bengal and also some of the western disturbances. So there was a local system that resulted in this kind of 624 millimeters of rainfall. So today I will be sharing on how we were able to evacuate 266 female, 224 male prior to this kind of events, though we had very less lead time, and also some of the strategies that we adopted during this monsoon. So how we intervened is first through our technologies. What we try to do is, although the region that I'm presenting is a area that is a very transboundary nature, that is only 35% of the catchment area lies in Nepal, whereas the 65% of the area lies in India. So there are some limitations in data, but based on the available data and under different return period scenarios, we identified what are the areas that could have some kind of inundation. So we developed a model. The household surveys were also carried out, and the house typology and every vulnerability components and also the exposure will then explored. So based on that, we kind of categorize the households by overlaying the layers of hazards, vulnerability, and exposure, and then we identified the households which had like persons with disability or maybe other different types of vulnerable people. So those kind of information were already available with the municipality, and we had this kind of visualization that was available in the municipality. So because we lacked data, what we also tried to do is we developed some model, inundation model, and then we also checked it with the historical inundation that happened in the past. So this is how we validated our models. And then we had some for the quick response, not just the response, but for the early action and early evacuation, we have had this kind of community-led plaques in the households, where the households that had some severe vulnerability were provided with such kind of plaques and also information. Besides, we also had some proactive ways of making people sensitized about how this kind of hazards can turn into disasters. So we just developed some kind of household level disaster preparedness plan, and that were distributed to all the households. Besides that, based on the information that we derived, we also developed this kind of community map boards, which were installed in the communities, and they would know what are the areas that we need to evacuate, where are the shelters that we need to travel. So those kind of information were available in the communities. And then the whole government was in the process. So you can see some of the pictures. The pictures on the right were people, those who evacuated earlier and were not affected by the floods. Besides, we also had some ground level interventions. We had RLS sensors that were kept in the rivers, and then some manual gauge stations that were also that were checked by the communities, and then the sirens that could notify people in advance. Besides, we also worked with the Department of Hydrology and Meteorology, and we did a piloting of impact-based weather forecasting this year. So before that Cloudburst event, we were like 2 days prior to that event, we were provided with this IBF bulletin that suggested that there could be some severe problems. And then that was how we started working in the field. And then with the help of SMS, IBRs, community sirens, and then the social media channels, we kind of communicated with all the households to stay them in the safer areas. And also we have like community disaster management committees are there. You can see this is the intervention municipality. So the right river is the Mahakali River, and the left one is the community settlement. So the pin marks are the community disaster management committee that were really proactive. And during this period, we had so many IVR messages that were sent to their phones regarding to check about their conditions, whether they have already evacuated or not. And also those IVR were sent to notify people in advance. And besides, we also had developed the youth rosters who were very active and then contributed in overall disaster risk reduction cycle. As you can see, some of the youths who were trained on what kind of interventions that they need to do. So the early actions were kind of evacuations, group cash transfers to facilitate the persons who have evacuated in the shelter homes, and also some cash voucher assistance. Besides, we also promoted some community-based mechanism. As you can see there, the staff goes, the painted in the in different structures were also available to the communities. And besides some of the response, if I mean the municipality also had developed some early action protocols. So whenever there is some kind of potential events, likelihood of some kind of potential event, then those kind of early action protocols are activated, and then all of the stakeholders are defined with their designated roles and responsibilities. And then before any such event happen, people would actually do an early action so that they could reduce any kind of casualties or other losses. So after the floods, you can see our volunteers also went to different areas, and then based on the different inundation level and the damages that occur in the region, we are now currently developing depth damage curve for this region, and also developing physical vulnerability curve. So besides that, the community were also really proactive, and they used to send us any kind of incidents that would occur in the regions. For instance, if there is any disturbances in the road, or any bridge has collapsed, then they would just send those kind of data to the municipality for some proactive cases. So this is how the community also worked hand in hand. And together we worked in the four pillars of early warning systems. So it's about disaster risk knowledge, and then the disaster warning dissemination, preparedness and response, and also the observations. So overall, what I want to share is, because of those kind of interventions, those were all in linked. But for instance, before such kind of disasters, all the households were mapped, and some community map boards were there. The households were sensitized about the potential risks that they could have, and then based on the different models that we developed, we also established some thresholds. And then there was some regular monitoring of forecast, whether there is a likelihood of such kind of events and or not. So based on those kind of forecast information, we then communicated the communities, and then we also adopted early action. So it worked in a cycle. And thus, despite we had, like, during 1993 we had around 1,300 lives lost, but for this year 2024, especially in Dodara Chandani, because we were able to apply these kind of things, there were no any casualties. So there are few lessons learned that we have gathered during this implementation process. So the most important part is the transboundary collaboration. So disaster does not just look after the administrative boundaries. And what is also very essential is we are kind of living in risks. So we are actually kind of adapting with the situations. There are instances where we can also apply mitigation, but again, there is a term called residual risk. So despite all the interventions that we do, and because of the resource constraint also, everything is not possible. So there actually lies the residual risk. So it is our duty to make those kind of residual risks very minimum. And also it is also very important to work in the preparedness, as identified all the cycles that we undergo during our early warning system. So these things should be implemented, and the availability of very granular level information will be very important for the government and also different stakeholders to carry out some kind of interventions prior to disaster. So we were implementing this project, we were also awarded with some grants that were available from GSMA ADPCs, and then we are working with the stakeholders under the leadership of local government. So I would like to limit my presentation here, but I'd be happy to hear any queries that if you have in the later half. Thank you so much.
Thank you, Suraj, for demonstrating the proactive use of technology, early warning, and local network where the area experienced zero casualties. And now I'll call upon Dr. Manish Mokal to give his address.
Good afternoon, ladies and gentlemen. First, I would like to thank the chairman and the ACECC for giving me this opportunity. The previous speakers have already set the context of the problem at hand and what are the kind of issues that we face in the cyclone. I will try to throw some light about how some advanced materials and technologies can be used to build a more resilient structure in cyclone-prone area. The Bay of Bengal region is a very active region as far as cyclones is concerned. It experiences almost 4 times more cyclones as compared to the Arabian Sea, and the number and the intensities are only growing. If we look at the landfall pattern, we can see that almost 60% of those cyclones hit the eastern coast of India, and about 30% hit the Bangladesh and the Myanmar sea coast. During the cyclones, the winds can go as high as 200 kilometers per hour, and the area experiences very heavy rainfall.
Dr. Mokal, the screen is not changing here for us.
Just hold on, we'll sort out the issue. You need to share.
We can see the first page, and that's about it, and not in the presentation mode, that too.
But they are only able to see the first page.
Maybe we can share the entire screen.
I think we should change for the slide view because of the PPS are a little difficult to see for the every slide. So we need to change for the wide view. It is more comfortable.
Yeah, now it's visible.
So I'll quickly take you through again. If you look at the landfall pattern, about 60% of the cyclones hit the Indian and about 30% on the Bangladesh and the Myanmar. We have very high speeds of the wind, and the rainfalls are also very severe. This is not working. Okay, go to the next slide. You'll have to help me out now. The cyclones have a catastrophic effect on the area. It leads to failure of roads. It leads to collapse of bridges. It leads to collapse of buildings. It leads a trail of destruction in the entire area where the cyclone hits. Of course, there are many structures which have stood the test of time, and in spite of experiencing many cyclones, have stood tall without any major damages to the structures. We all know that if we want to have a structure resilient to the cyclones, then we need to take very good consideration of the wind loading. The design needs to be very aerodynamic. The foundations needs to be very robust. There has to be some amount of redundancy in the structural design, and we need to have very good material that we use for the construction. Since my topic is about the material, I'll be throwing some light on use of advanced materials and technology for building resilient structures with the focus on achieving high strength, high flexibility where required, high durability, and low maintenance. One of the most promising technology is the use of ultra high performance concrete. This concrete not only has very high compressive strength, but it also has very high flexural strength, very high modulus of elasticity, and very high fracture energy due to uniform distribution of micro steel fibers that we add into the concrete. The water cement ratios here are very low, so the permeability is low and the durability is very high. Because of the ultra high strength, the members are very slender. You have a very aerodynamic design. You also have lower dead load, and the structure is very ductile and has very high impact. This is one of the projects where ultra high performance concrete was very beginning. You can see that the members are very slender. The shape is very aerodynamic. There are many projects in India which is also now using this ultra high performance concrete technology. One project where ultra high performance concrete girders are being used as a part of cable stayed bridge, which is being built in a valley section. Having looked at the concrete technology with very high strength, now let us look at something which is very flexible, called as the bendable concrete. The bendable concrete has got very high utility in areas where the structures are having high deflection, in earthquake and cyclone-prone areas. This concrete can have very good utility in use of, instead of using the conventional expansion joint, you can use bendable concrete as a replacement. The bendability is what we get by using polyvinyl alcohol fibers in the. We all know that the conventional expansion joints can rust and if not maintained properly, will not function with optimum living cycle. It can cause additional stresses develop in the structure and can lead to. We can use the bendable concrete as a replacement of the conventional expansion joint and expand and contract across the requirement without requiring any major. Ayeyarwaddy Hokkaido, Japan is one such project where was built using bendable concrete instead of conventional. So we know that when a structure undergoes high deflection, it develops a lot of microcracks. So these microcracks are not visible to the naked eye. Over a period of time, they will widen, then become visible, and then some action for repair is taken. So imagine if we have concrete technology, a mechanism by which the minute you have these microcracks developed, you are able to heal those cracks or heal those cracks by some mechanism. If that happens, then the external is going to be low, the deterioration to the concrete is going to be very low, and the service life of the structure is very high. There are a couple of ways by which this self-healing mechanism can be built. One lot of research is going on the use of bacterial concrete. This is a certain kind of bacteria incorporated into the concrete at the time of production, and it remains dormant in the concrete as long as the structure. The minute there are any micro cracks that develop and water starts into it, these bacteria get activated and in presence of water and oxygen, these produce acid carbonate, thereby giving the crack at the micro level, it can reduce the deterioration of the. The other way of achieving a self-healing is by using crystalline-based powder. These not only grow crystals in the pores, capillaries, and microcracks, also reduces the permeability, thereby increasing the durability of the acts as self-healing, the water processing process as well as the Preparedness project has used this technology extensively. In India also there are many projects where now so apart from making good concrete, it is also very important that we design the structure in such a way that the rate of corrosion of the reinforcement is especially important in case of ACECC. Similarly, when we compact it, the excess water will try to move. There is no way to go, so it stays there in the cover zone. Now, our cover zone was line of defense. If the NCR provides a carbon dioxide into the concrete, this will affect your corrosion. Now, we have something called as controlled permeability formwork, where you like a clock. Now, when the excess water is expelled towards the surface of the water, drain down the approximate ratio of your cover zone, increasing the durability of your concrete. The Ahmedabad in China is one project where it has been extended for all the concrete back to the side. Another way of reducing the rate of the corrosion of the base by using corrosion. Eventually, now a new generation powder-based corrosion has come up and now it is much more effective. Especially metro. A very good structure is also important that the head of the structure. Maybe 1 year or 3 years, depending upon the physicality, where the engineer will go and manually check. Nowadays, there are many good sensors which are available. You can check these things, pain, detection, because using IoT can be immediately relate down to the user, can have one-time information about the health of the structure at any given point of time, and can take corrective action as well. Of course, the futuristic idea would be to have step sensing functions for art structure. A lot of research is going on this, that they have carbon fibers in this form. It produces a kind of an electrical impulse, and they can very minute check any changes in the quickly relate the information to the engineer who will be able to get. The talking of technology, the regulation can be used a lot. We understand that for any physical structure, cyclone-prone area, wind engineering analysis is a part of that. Generally done using a calculation. Now it has been shown that engineers can go for many more items about that. Yes, also predict the future cyclone case data. For the forum, AI these structures must be built with some amount of additional factor of safety. User-proof update our codes and standards frequently that incorporate the latest technology. After every major cyclone, we need to carry out SMS also need to cyclone temporary for having discussed the few technologies, let us see how we can build a cyclone. We need to have an aerodynamic design for ultra high performance bendable form. We need to have lower maintenance to our structure. Use of technology like self-heating pumps and use the rate of good. Something other is something which we need after every cycle. It's not go and do. We must not forget every structure that we have.
Thank you, Dr. Manish, for elaborating comprehensively on the ultra-high performance concrete, the bendable concrete, and the self-healing material, alongside use of smart sensors and AI-driven design tools. Now I request Mr. Soipa Yong from the Federation of Myanmar Engineering Societies. He is in Australia and is with us to deliver his talk.
Thank you. Can you hear me?
Yes, we are able to hear you. We are able
Thank
to
you,
hear you.
sir. Thank you, sir. Okay, thank you so much for invitation for this seminar. It is very nice. The professor from the Indian also already mentioned about the importance of the policy framework in the disaster event. So some of my colleagues from the Nepal and India also they mentioned about the technology and some of the advanced technology in the disaster evacuation is very important. Yeah, for my slide for my presentation, I would like to be more digging for how to community involvement is very important for disaster risk reductions and community resilience. Because even though we have so many technology, even though we have so many framework and policy, if without the involvement of the community in disaster management, it is very difficult. Because of the community is one of the vulnerable people during the disaster time. So now my presentation is about the community-based disaster preparedness and response strategy in our country. It is one of the case study in the Hinthada Township. It is one of the data region. So before 2025, we have this project, we have a collaboration together with the Federations of Myanmar Engineering Society and one of the Japanese organization, we call the ACECC. It is one of the joint project in our country. This project is supported by the Ministry of Foreign Affairs, Japan. So now I would like to share my slide. So now, in our country, it's a very big earthquake happened and many community and many public or private infrastructure is severely damaged. So because of we have a little delay for emergency response, even though we have a Myanmar action plan for disaster risk reduction, Myanmar National Emergency Operations Center, but we have a very limitation allocation budget after the political crisis in our country. So then it is a very important for the more collaboration among all of the country now. Different kinds of the organizations and different countries also supporting for second rescue and emergency process. So it is very good, and now we can be more better for our future community resilience. So this in my slide. According to my presentation, here is some of the outline presentation for my presentation. So you can see some of the picture in here. So even though 2008 Naked cyclone, after that we have one of the collaboration project with Japanese organizations and Myanmar Engineering Society. The project is we have thinking for the capacity building for disaster reductions and environmental management in the affected area. So more than I think 12 years working together with the Japanese organization, but this project started after the 2005 military coup. So now we have trying to be more how to say emergency response in during the earthquake time also. So this situations of the project area, as I mentioned before, this area is a very flooding area. 2050, the common flooding and cyclone die. This area is a very damaged. So according to our project with the CECC and Myanmar Engineering Society, we have a plan for some of the school can shut down in this area. Why we are trying to engage that kinds of the project? Actually, we have one of the coastal community resilient index survey in my country. It is one of the joint project together with Yangon Technological University, Disaster Management Department, CECC and MBS. So according to this survey, we noticed this area is very affected for flood and cyclone. So we are thinking one of the school constructor project in this area. So after that, we have an starting for this project in 2018 because in this area, according to their historical hazards in the Ayeyarwaddy data region, they have so many flood and cyclone because many kinds of the muddy hazards in this area. So we are trying to be more sustainable development in this project. So actually, we are working in Myanmar. We have some of the emergency relief process, capacity building for disaster risk reduction, community and school-based disaster risk reduction, disaster management research. So from this framework, we are working together with the Myanmar Engineering Society and CECC Japan for enhance the capacity building for disaster risk reduction and environment in affected area. Actually, this project have some of the objective because during the disaster time, the children are very difficult for their education community. So how we can enhance for education community? Second one is there is no disaster management plan or there is no disaster management culture in this region. So we want to be motivate and we trying to enhance for disaster preparedness and mitigation measurement. Especially, they have no action plan. So we are trying to take the action plan for the action plan without any kinds of the awareness or capacity building for disaster reduction. It is very difficult. So we are trying to enhance resilience through disaster awareness for school and community. So you can see this is our project area. It is a Ayeyarwaddy data region. So one of the big dike also in this area. Some of the school is outside of the dike and some of the school is inside of the dike. So because of the Ayeyarwaddy river is separated by the dike. So according to the map, this area is in the rainy season time, they have always flooding more than 3 men. So you can see there is one of the Ayeyarwaddy dike. So this dike is nearly more than 200 miles. There's so many historical hazards for flooding and cyclone in this area. So we are choosing this area for more resilient community and school constructor project. So you can see there is a 3 main issue of the previous school. So the issue one, there are so many handful facility for the children. Second one is even though they have a school during the rainy season, the disaster time, they cannot attend for their schools and they have very difficult for their education community. So the third one is even though they have a disaster, there is no evacuation center like school constructor. So we are thinking how to be enhanced and how to be solve that kinds of program. Yeah, there is their hazard profile in their village. So it is a major contribution to the community-based disaster preparedness and response strategy. In my presentation, I would like to mention about the 4 topics. The first one is community involvement in disaster preparedness. Second one is a community timeline for disaster preparedness and response. The third one is how to be integration for local indigenous knowledge into the science-based knowledge. The last one is we have an enhancement for the training for capacity building for disaster risk reduction in the area. So it is the main how to say the objective of this topic. Because of it is very important for community participation in disaster management. So we have been trying to take for some kinds of the framework for community-based disaster reduction. Second one, before the framework, we are digging for what is their hazards, what kinds of vulnerability, what is their resources and capacity, and some kinds of the evaluation method. The third one is we analyze and we develop for community-based disaster management plan. So there is some of our process for hazards vulnerability and capacity analysis. So first, all of the villagers and our project member is trying to understand about what is the historical hazards, and then the clarify and the identification for the vulnerability assessment. The last one is what kinds of the capacity assessment is already existing in their region and how do we integrate for our project. So according to their how to say discussion and explanation, we are trying to take for disaster task force committee. Yeah, so for instance, when they have no that kinds of the activity, so we are focused for how to take for the disaster management plan, what kinds of committee, what kinds of disaster risk reduction task force should be in their committee, who can be participate in that kinds of the committee. So we have so many projects because of this project is a 2-year project. So there is, there are community disaster management plan. You can see there is a different kinds of the committee. Yeah, the first one is like a early warning committee. Second one is a second recruit committee. The third one is a disaster management committee, a first aid and primary healthcare facility. Next one is a disaster rehabilitation and response committee. The next one is a trainings committee, and the last one is a financial support committee. So we organize to take that kinds of the disaster management in their region. So for this, some of the activity, because of that, they don't know exactly what is the risk, what is the disaster, what is the hazards, what is the vulnerability. So we try to integrate in their education curriculum, especially our target participant is a teacher, community people, and student. So we are trying to take that kinds of the planning through discussion. The first one, we established for the disaster management committee. After that, we are collecting that kinds of people for enhancing capacity building for different kinds of the training. So when we taking care for different kinds of the training, we collaborate together with like a fire safety department, disaster management department, irrigation department, because we're trying to take not only our capacity training for them, but also we have been thinking for different kinds of the stakeholder in our country. So after that, we try to take some kinds of the timeline, because in this area, they are flooding area. So we have the four scenario. The first one is a emergency preparation state. Second one is a emergency state 1. It is a danger level of the flooding 44 feet. The third one is a early warning system. At this time, they can get from some of the warning from the Department of Meteorology, Hydrology, and Education Department. The last one is an emergency state for alert level. So according to the framework, we are thinking for which level, what kinds of activity they need to do. So we have an disaster management plan and disaster management member. So we try to understand about all of the process of disaster management system for flood. So you can see it is a disaster management committee. Mostly disaster management committee members are school teachers and principals. Because of the we support for school and disaster. So this disaster is not only purpose for the education community, but also for community disaster. During the disaster time, the community people can stay and they can evacuate. So we have different kinds of purpose. So during the under the disaster management committee, school teachers and principals are taken care for this process. So the next one is a first aid and primary healthcare facility. So for this committee, we are working together with the Myanmar Red Cross committee, some of the head department, so they can get more trainings and they can get more capacity building for their committee. So because only federations of the engineering society and CECC can enhance some kinds of the training for like a construction, some disaster risk reduction training, but we have we need to more upgrade for some training like water sanitation and hygiene, first aid. So in this time, we collaborate together with the different stakeholders in our country. So you can see it is a relief and resettlement committee. The last one is
sorry to interrupt you. Can you just cover just the key parts now? We are actually overshooting our time.
Okay, yeah. Yeah, there is it is a die. In here, you can see some of the die have an emergency security system. So for this die, irrigation department is taking care. Actually, in this area, irrigation department is taking care for the die management. the first involvement people is a community. Because of the community they trying to more security for their dike system. If dike break down, that is a very big issue for the flooding. So in this area, not only taken care by the government side, but also the community involvement is also very important. You can see some of the community peoples are participation in this process for early warning system, as well as disseminating information to the community. So now I would like to explain about another slide. Even though they have that kinds of local knowledge, it is very important for integrating knowledge. I mean the scientific knowledge into indigenous knowledge is also very important. So second one is for the better early warning system, they have some of the activity for capacity building on teachers and young graduate community. And then the people need to be active participation in community-based disaster management plan. So you can see they have a depleted strategy for the disaster risk reduction, especially for the flood-prone area. Most of their housing is a more high level, and some of their drinking water system and all of the house have a security boat also. So this is a kind of the depleted strategy for the community people. So in our society and CECC project, we also support for some of the early warning and recording for like a atmosphere pressure, temperature, humidity. So that kinds of machine also very useful for them. So they always recording the height level of the flood level, and during the school time, they have already recording, and they already listen for the information from the government, especially from the Department of Meteorology and Hydrology. They have a recording water level by Department of Meteorology and Hydrology also. So there is kinds of they have existing knowledge. So we have some kinds of the scientific knowledge into their local knowledge. So you can see in this slide, there is a different men have a different kinds of the training. So the first one is a business disaster reduction training. Second one is a hazard mapping, and then they need to understand about the mechanism of the effect and rain, water and sanitation and hygiene, and then they learn about the first aid. And then they have a planning for the disaster management plan, including the firefighting course and some kinds of the time management system. And in the October, they have a attending training for the disaster management. But they need to understand how to be humanitarian standards and SPIA project also, because of the one disaster is coming. How to be emergency response for that kinds of disaster. So we have different kinds of the training in our project. So we arrange for some kinds of the disaster sharing knowledge. It is together with the education department and some disaster management training center. So it means the community people can learn not only how to say the theoretical knowledge, but also they need to understand some kinds of the practical knowledge with different stakeholders. So you can see there is some of the training activity. So we after our school construction project finished, we celebrate we trying for one of the evaluation drill also. So by doing that kinds of the drill, they more understand about the process of the disaster and how to be and participate in emergency response. There is some of the our school construction activity. So we are sharing for some of the disaster reduction activity, as well as we have some activity is in line with the Sustainable Development Goal. So it is my final slide. I would like to recommendation for some of the activity in my project. Even though this school is now they can be more education community, but they need to more collaboration among school and community. After our project finish, they have not so much activity, but they have a school disaster management plan and village disaster management plan. So during the flooding time in 2021 and 2022, they can be well managed, but they have still need to understand about the ownership and inclusion there. Because of the, you can see there is some of the activity in the project itself, they can ongoing process, but without supporting from the how to say project like a Federation of Myanmar Engineering Society or CECC, our Japan project, we cannot continue supporting. So they have a need to understand about how to be continually, how to say, development for their future curriculum. So I think in our country, even though national level, we have a Myanmar action plan for disaster risk reductions and national disaster management committee. So this need to be more action. Even though in this current situation is very difficult for our country, so how to be collaboration with that kinds of action plan during that kinds of the earthquake-prone area. Okay, thank you so much.
Thank you, Mr. Sohpa for very passionately covering your case study, which demonstrated how the grassroots ownership, training, and indigenous knowledge can strengthen the disaster response capacity. Now we are done with the presentations. Now, because of paucity of time and also since we are in a hybrid mode, I will moderate this interactive session for the benefit of all. My first question is to Professor Murthy. Sir, you spoke about how our current building rules actually don't always match up the real risks from cyclones and floods. And you also did mention time and again about the dignity to mankind, which is the need of the hour. You did develop on certain short-term and long-term strategies. But within these, sir, can you, for our understanding, can you just identify 2 or 3 critical steps which the engineers and government agencies they need to undertake in the next, say, 4 to 5 years to make sure
Yes, sir.
that we begin designing buildings and infrastructure that are better prepared for these growing dangers?
Thank you, Junal Sab. I have 3 points. First point is that we need to have a GIS-based database which has the digital elevation model, the flood levels in the past events, and considering extreme climate change conditions also, what are the future projections? And then what are the assets that are going to be inundated in that? So this is my first request, is that we need to develop in all cyclone-prone areas this GIS database. So we know our problem. We don't have to do any computations. If you know your water level, that will tell us how much at risk we are as far as the flood waters are concerned. Second one comes to structural design to resist wind effects. Right now, what is happening is that they are living in low-lying areas. We evacuate them, take them to temporary shelters. But in the meantime, their houses are all drowned or washed away or damaged. Now, which means that they need to restart again. Every year, we cannot make them restart. So my suggestion will be that in the short run, we may have to adopt a system which is generally not the best solution, but stilted structures. It might cost a little more, but it requires great hand-holding by the engineering community for the locals because they need to use cost-effective solutions. So stilted structures is a short-term solution for them because they cannot migrate every time. But more importantly, to resist the wind effects is the bigger challenge. Stilted structures have to be heavy also, otherwise they will get completely uplifted by the wind effects. That's my second suggestion on the design side. But the third one is a more long-term story. Not long-term, but it's more formal story, which is from the standards point of view, is that the principles adopted in the case of wind resistant design or earthquake resistant design for allowing damage up to a certain level cannot be adopted for flood resistance, flood resilience. And hence, there is a need to reconsider the differential damage philosophy that we have been adopting for earthquake and other prominent hazards in the case of flood. Here, what we are saying is that we cannot afford to lose the infrastructure, be it houses, be it other facilities. So the standards have to depart from the risk-based approach to the resilience-based approach. So for the standards committees and standards organizations, that is my request. For the governments, I think they need to do a change of bylaws quickly and bring in the option of letting people stay there only, but make their existing structures robust. But I think the quicker disaster management people, governments will be benefited significantly by looking at GIS databases with the elevation, flood levels, and the assets which are at risk. I'll stop here, General Saab.
Okay. Thank you, sir. Actually, with this response, or three-step response of yours, you have actually given us a way ahead for the next 6 months. Till we culminate in SICA 10, the technical committee will continue to work on these three issues related to GIS data, the design side of it, as also the standards and policies from the government point of view. So our focus for the next 6 months will continue to be working on these three issues. Moving further now, my next question on behalf of all of you is to Dr. Manish Mokal. Sir, you suggested designing structures with additional factor of safety to future-proof them. That is understandable and it is desirable also. But how do you balance this with cost efficiency, especially in developing countries in our region where budgets are always constrained?
Thank you for the question and very pertinent. Cost is something that needs to be looked at. But when we look at the cost of any structure, let us not just look at the cost of building the structure. Let us look at the life cycle cost of the structure. Suppose I am building a bridge today and very couple of years, I need to go for some major maintenance and repairs because of the cyclone damage that happens. That would lead to a more cost at the end of the day. What could help us in reducing the cost also at the time of construction could be, though we have an additional factor of safety, let us see that we do not build these structures with too many wastages. We use sustainable material, locally available material, so the cost of material can be brought down. Use supplementary cementitious material like fly ash, slag, which is available at a much lower cost as compared to cement. And that is how we can try to control the cost at the time of construction as well as the life cycle cost. Thank you.
Thank you, sir. Anyone else in the audience related to these structures, if anyone want to or wish to, or anyone, all those who are online, they can also please. Thank you, Dr. Manish. My next question is to Suraj Gautam. What are the key limitations in the current early warning systems, and how do you envision that AI or frontier technologies addressing them in the next disaster as and when we face it?
Thank you so much, sir. So talking about the early warning system, so it is not just about installation of equipments or instruments. Sorry, but we have to work in the all stages of of early warning system. So right now, what I feel, what we have been witnessing in our region is we've always been talking about we have data limitations or something like that. But again, at the ground reality, it's not just about the data limitations, but you have to work with what you have. So there's no other choice. So I mean, the use of current the machine learning and the artificial intelligence has been evolving a lot. So by the use of this kind of technologies and also the frontier technologies, I think it has been kind of easy to evaluate and also to understand the risk. So what we need to first develop is we need to develop the risk informed communities, because without having risk informed communities, it will be difficult to implement all sort of this kind of interventions. And as I also mentioned about the understanding about the residual risk and also the acceptance level of risks. What is the amount of risk that could be actually accepted? So this is also something that we need to have proper understanding. And the government of Nepal is investing in a lot in disseminating information. So far it has been going good. But again, the major thing where we need intervention or where we need to work is the fourth stage of the warning system. It is about strengthening the preparedness and also the mitigation activities, so that we are able to cope up with all these kind of potential impacts that could result. And also there could be some false alarms as well. So despite doing all the hard work, all we need to believe in is no regret or low regret policy. So as we also heard from one of our presenters about the life cycle cost, so that is also something that we need to take care upon. And if we can actually utilize all of these components, which is also now aided by the different frontier technologies that is available now, then I think it will be easy for us to adapt and also operationalize the existing early warning systems. Thank you.
Thank you, Gautam. I think I'll sum up what he's trying to say is that all the frontier tools and the AI, they will enable community level anticipatory actions before the disaster strikes. I think that is the crux of what he wanted to say. And my next question is to Mr. Aung. How can engineers and technical experts they can work more closely with the community leaders and schools, since you presented a case study earlier, to build a culture of resilience from the ground up, from the bottom up stage?
Yes, thank you so much for your question. Yeah, it is very, very important for technology for the community people, also very important, especially when we start that kinds of project in this area. Most of the community people, especially even though the teachers are also not so much familiar with the technology. Because sometimes when we explain for some kinds of the training, it is concerned with the science, so they are very difficult to understand. So in this time, we have an adaptation for how to be explained for them. And so because of one of the problem in our country is that there is no disaster management or there is no disaster risk reduction education in the school curriculum. So it is very important how do we integrate it for existing curriculum for disaster management in our country. So I think, even though any kinds of the project in our country, the first respondent for the community is very important. So how do we motivate, how do we enhance for capacity building for that? For instance, when you can see the experience or that the current earthquake situation in Thai. So even though so many organizations are trying to take for capacity building, but they have very limitation for how to say the predicate drill or predicate evacuation. So there is one of the constraint on barrier in our country. So I think, we need to how to say accurate for some technology, but even though local people are difficult to understand for that kinds of technology, how we can explore, how we can integration, it is very important for our country.
Okay, thank you. I would add that all the training programs, they should be context sensitive, and all the resilience curriculum in the school curriculum should be so embedded that it becomes a lived experience for the community. So that is what the sense of what Mr. Ong was trying to say.
Thank you,
Is
sir.
there no further questions? Yeah. Is there any further questions, or should I close the session now? Okay. Ladies and gentlemen, as we draw this enriching session to a close, I want to sincerely thank each one of you, my distinguished speakers, my respected Professor C.V.R. Murthy, Engineer Suraj Gautam, Dr. Manish Mokal, and Mr. Sopa Yong for their deeply insightful and action-oriented presentations towards this uh, cyclone problem. Now, today's discussion have reinforced that resilience is not just a design attribute, it is a strategic imperative. We have seen how innovation in materials, predictive technology, community engagement, and forward thinking policy can collectively build infrastructure that stands strong not only against the winds and floods of today, but also the uncertainties of tomorrow. Let us all together take forward the spirit of collaboration and innovation we witness today and continue to build bridges, both physical and institutional, across borders, sectors, and communities. Thank you once again for your participation. So I'm very grateful and obliged. Thank you.
Thank you
Thank you,
so
Jen
much.
sir.
Thank you so
Thank you so
much.
much.
Thank you so much for this wonderful opportunity.
Thank you so much, Professor, for your sharing. It is very nice for policy matter. Thank you so much. Yeah.
Thank you, Professor Aung. We'll keep in touch, and I'll send you the presentation so
Thank
that
you,
we
sir.
can start the discussion. Yes.
Yes, sir.
Thank
Thank
you.
you, sir. Yeah.